Welcome to the video for section 3.3, Systems of Inequalities. Our focus today is going to be how to solve a system of linear inequalities by graphing. Now, here is your joke for the day. What do mathematicians eat on Halloween? Pumpkin pie, as in pi, P-I, as in 3.14, blah, 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 blah. Okay, we're going to start by talking about the steps that we use to solve a system of linear inequalities. And we're going to be using example 13 as I go through these steps, specifically problem 13a. Now, step 1, it says to graph the first inequality. So the first inequality on 13a is y is less than or equal to negative 2x plus 4. So I go ahead and I graph that line. It's already in slope-intercept form. Then I have to shade. Hopefully you remember that in order to know where to shade, I have to pick a point. If 0, 0 is not on the line, I would recommend that you test 0, 0. Step 2, we're going to graph the second inequality. That's going to be y is greater than x minus 3. Again, we need to pick a point not on that line, test it, and then shade where it's true. So the solution of both inequalities is where the shaded regions overlap. Then our last step, we need to check the solution by picking a point in that overlap region. You have to make sure that you check it in both inequalities and that it holds true for both of them. Alright, so let's go ahead and practice now with 13a. Okay, now we're going to start by actually graphing 13a. So we have both of our systems, or both of our lines. If you notice, both lines, or both inequalities, are already solved for y, so they are in slope-intercept form. So we need to start by finding the slope and the y-intercept. So the first inequality, we have a slope of negative 2 and a y-intercept of 4. So I'm going to go ahead and draw that line, y-intercept of 4, and I go down 2 over 1. Now, do I want to use a solid line or a dashed line? Hoping that you all said solid because we're using less than or equal to symbol. You need to make sure that you're using rulers on your paper as well. Okay, I always shade with inequalities. So we need to pick a point not on the line, and again I'm going to pick 0, 0. And I'm going to test that into just the first inequality. So 0 is less than or equal to negative 2 times 0 plus 4. Is 0 less than or equal to 4? That is true. So we are going to just lightly shade where 0, 0 is. Okay, the next one. Y is greater than x minus 3. Again, you should be able to find your slope. The slope is a coefficient of x, so it's going to be 1. Your y-intercept is negative 3. So I'm going to go to negative 3, and then from there, up 1 over 1. And it is a dashed line because we're using the symbol greater than. Okay, now picking up a point that's not on that line, and again 0, 0 works. So I have 0 is greater than 0 minus 3. Is 0 greater than negative 3? Yep, it is. That's true. So then I want to shade where 0, 0 is. So then the answer, all those points that would work in both inequalities, are going to be right in here. I would recommend that when you do these problems, you work with colored pencils, a different color for each inequality. Okay, let's try another problem. 13b, we have x minus 3y is less than 6. Well, for that inequality, you need to solve it for y, put it in slope-intercept form. So, I'm going to go ahead and subtract the x over. I get negative 3y is less than 6 minus x. And I now need to divide everything by negative 3. But you need to remember that when you work with inequalities and you divide or multiply by a negative, your inequality symbol switches. So now I have y is greater than negative 2 plus 1/3 x. Alright, now it's in slope-intercept form. My slope is 1/3. My y-intercept is negative 2. So I'm going to negative 2. From negative 2, I go up 1 over 3. And you need to be using a dashed line. Okay, let's test 0, 0. And I can either choose to test it in this equation or in the original. I'm going to go back and test it in the original. So I have 0 minus 3 times 0 is less than 6. So is 0 less than 6? Yes. I'm just going to lightly shade. Alright, let's do the second inequality. I'm going to work with red. I'm going to solve the second inequality for y. I can do that one in one step. We just need to subtract the 2x. Alright, so our slope is negative 2, and the y-intercept is 1.5. So I'm going to go to 1.5. And from there I go down 2 over 1. And I want to use a dash line for this one as well. Okay? I notice 0, 0 is not on that line, so then I can use 0, 0 to test. So 2 times 0 plus 0 is greater than 1.5. Is 0 greater than 1.5? That's false. So I don't want to test where 0, 0 is. I'm going to test on the other side of the red line. Alright, so hopefully you see that this region right here is where they overlap at. Okay. Now for example 14, I'm only going to start with writing the inequalities for you, and you're going to finish it on your own. So let's get started. Alex is now marketing his weekend job abilities to other neighbors. He is advertising $8 per hour for painting and $10 per hour for yard work. He would like to make at least $60 a day, but can only work a maximum of 7 hours. Write and graph a system. If I was you, I'd probably set up a little table. So we're doing two things here. He is painting and doing yard work. And then of course we want to focus on our totals. Your totals are going to tell you how you write your inequalities. So we want to make at least $60 a day. So what that tells me is that one of my inequalities is just going to be on money, or the focus is on money. And then I have another total that says he can work no more than 7 hours. Well, a maximum of 7 hours means less than or equal to 7 hours. So my second inequality is going to be focused on the number of hours he works. And I did forget in the first inequality, he wants to make at least $60. That's going to be greater than or equal to 60. Okay, so I'm going to have, let's see, X is going to represent the number of hours painting. Y is going to represent the number of hours doing yard work. And if I combine the number of hours painting with yard work, that's my first inequality. X plus Y is less than or equal to 7. Now, as far as the money inequality goes, he does $8 per hour painting. So the money that he brings in painting is going to be multiplied by the number of hours he works times 8. In the yard work, he's $10 per hour. So I take the number of hours he does yard work, multiply that by 10. That sum needs to be greater than or equal to 60. So these are my inequalities. 8x plus 10y is greater than or equal to 60. And x plus y is less than or equal to 7. You need to graph both of those inequalities. You can choose to put them in slope-intercept form or graph by the intercept methods. Make sure you test points and you shade. Now, I only put the first quadrant on here because we're talking about the number of hours, and we can't have negative hours. Good luck. Let me know if you have any questions. For number 15 on your notes, we're going to start that in class, so do not do 15 on your own.